Bon, tout à fait à l'heure. Bonjour à toutes et à tous.
And we are right on time. Thank you, everyone. Thank you for all being here. We have over 600 people who signed up and who are attending, whether here or in the other room. This really shows how much interest today's topic is sparking, and also how new such a topic is regarding environmental services. My name is Diana Luda, and I'm delighted to welcome you here. This is a magical place, steeped in history, and at the same time extremely modern in its thinking. So we're about to start a conference on artificial intelligence. This is a topic that is not only at the center of current events, but also fundamental in shaping the future of our businesses. It's important for Veolia's businesses at large and also for the future of our society. And for those of you who may not know, the Institute, for the past 25 years, Institut Veolia has served as a platform for analysis and dialogue that brings together various stakeholders, academia, business leaders, civil society, politicians. And our goal is to decode the major challenges of ecological transformation and also place in the public arena a number of aspects, while at the same time fueling of Veolia's think tanks and strategic vision. So we will explore critical themes such as environmental health, resource efficiency, innovation, the circular economy, and soon, because that's the next edition, and we will hold a conference to which you're all invited, we'll soon hold a conference on the connection between biodiversity and health. And as you well know, artificial intelligence is raising tremendous hopes as well as deep questions. Last time in October, we dedicated a full day of discussion to this topic, and that is how an idea cropped up. And this idea is to contribute to the debate by looking more closely at both the positive and negative impacts of AI on environmental services. AI has very real water and energy costs, and we often hear about that, but there's something we hear less about. And I'm referring to the potential of AI to improve resource management. And this reflection led to the co-production of a publication of Microsoft. Because we have Amy, who's Microsoft's Director of Sustainability Science, and she's a member of a Foresight Committee. We also have a whole panel of academics. Unfortunately, Amy could not be with us today, but she has prepared a short video address in English.
Donc la revue s'appelle l'IA au service de l'énergie.
So the publication is entitled AI Serving Energy, Water, and Waste, and this publication is brand new. It was released just last week. Feel free to pick it up on your way out. I prefer hard copies, but it's probably better for the environment if you read it on our website. And also, as a member of our Foresight Committee, we're deeply honored to have Professor Philippe Aguillon. He's also here in this room. He teaches at the Collège de France, at INSEAD Institute, and also the London School of Economics. And as you all know, he was awarded the Nobel Prize in Economics in 2025. Philippe has contributed a highly insightful article to our publication, which is entitled, How Can AI Contribute to Energy Efficiency Goals in Industry? And this paper examines the net energy impact of AI in wastewater treatment, and more specifically in aeration systems. So it's quite a concept that we're keeping a close eye on. And so Philippe will officially open the conference by sharing his perspective on both the opportunities and the risks that AI presents for the environment. And this will be followed by a roundtable discussion moderated by David Ménaché, co-founder of Archipel & Co., with whom the Institute Veolia has collaborated for many years. And David coordinated the drafting of this publication, and I would like to thank him as well as his entire team. In order to explore today's key issues in depth, we have the privilege of welcoming an outstanding panel of experts, including Corinne de Bilbao, President of Microsoft France, Philippe Guillauzic, Head of AI at ADEME Agency, Albert Mege, a partner at Arthur D. Little and also the director of the Blue Shift Institute, and Fouad Mouache, Head of Architecture, Expertise and Engineering at Veolia. I warmly thank Fouad for stepping in at short notice. And we will, of course, leave time for questions from the audience, as well as our online attendance, before handing back to Philippe Aguillon for the closing remarks of this morning. And last but not least, I would like to extend my sincere thanks to the Collège de Bernardins for hosting us in this magnificent venue. Like I said, this place is steeped in history, and yet it is firmly focused on the future, particularly through its research center, which conducts cutting-edge work, including in the field of artificial intelligence. And I will now, without further ado, hand over to Anne-Laure de Montlhévaux, Deputy Director of the Research Center, who will introduce their activities. Thank you so much, and I wish you an excellent conference.
Eh bien, bienvenue dans ce lieu.
Welcome to this place, which was built in 1248. This is a Cistercian college, which is at the interface between the world and culture. Some of you have been here before, but we're delighted to welcome so many of you. We're particularly interested in your publication today because it matches some of the works carried out by our research center. Yes, our college has a research center bringing together nearly 270 researchers, and they're reflecting on the major trends and issues that are affecting today's world, as well as our societies and our citizens. So we are tackling those issues by bringing to the table different disciplines: social sciences, human sciences, theology, etc. Because, of course, this place has Christian roots, and we like to describe ourselves as a threshold, a space where dialogue between the church and the various components of society is fostered in the service of peace and truth. So what we like to do is disputatio. Disputatio means the art of dialogue, which was initiated by the monks in the Middle Ages. This college was founded by Lexington, a monk that came all the way from Oxford. And so this place was built in the 13th century, and until the French Revolution, a number of European individuals came here to train and to discuss key aspects pertaining to the exploration of the universe or even the wisdom of Scripture. And so this art of dialogue is something that we've been cultivating ever since. And this is why our research efforts enter into a dialogue with the rest of the world. So academia from across the world. We have researchers coming in from partnership universities, AgroParisTech, the CNRS Center, La Sorbonne, and choose a dialogue with our theologians. And we also have a dialogue with private sector companies. And this is what sparked our interest when we saw your forward-looking works on two different topics: AI on the one hand, and digital humanism, that's one of our departments, and also environmental humanity. We have 27 research projects structured around those 7 departments, and 2 of them include digital humanism and environmental humanity. And the next slide will show how our research center is organized. And today's discussions lie at the interface between those two topics in the top right-hand corner. So environmental humanity means that we tackle environmental issues. In this year, in particular, we'll hold a research seminar based on the issue of energy and lifestyles. And the energy transition is being looked at from the point of view of the humanities, from the point of view of society. Energy transformation means a change in our lifestyles in terms of ethics, in terms of culture, in terms of relationships and spirituality. So those research seminars are designed to think about energy and govern energy as a public good. And this is what drives our working groups. They're working on issue in connection with culture, technology, progress, what this means from the point of view of human beings, from the point of view of society. Our AI department is also called digital humanism. And like I said, how can we be human in this digital age without being naive or overly optimistic, without any kind of reductive and anthropomorphism? So how can we rely on the cultural philosophical tradition of humanism while we think about a relationship with progress? And can we too use technology in a way that is reflective? So this is what we're going to do with AI today. How can we use AI to serve the environmental transition? How do we make sure that this fosters human dignity and the general interest? And how do we continue to behave responsibly? Thank you. I wish you all a very interesting conference.
Amy Loers, Head of Sustainability Science and Innovation at Microsoft, and a member of the Veolia Institute's Foresight Committee. It's been a real pleasure to work with the Veolia Institute team to co-produce this report that we just released on AI for energy, water, and waste management, unlocking opportunities, navigating challenges, and learning from experience. This report brings together scholars and practitioners from around the world to examine how AI is already being used to manage some of our most critical systems, energy, water, and waste, and how it can be deployed at scale to address these solutions responsibly. It's organized around the 5 pillars drawn from Microsoft's AI and sustainability playbook. These include, first, investing in AI for sustainability. The second is building inclusive data and digital infrastructure. The third is minimizing resource use, expanding access to carbon-free energy, and supporting local communities. And the fourth is advancing AI policies and governance in support of sustainability. And finally, skilling the world to use AI technologies to advance sustainability. Now let me say a few words about why Microsoft has partnered with Veolia on this report. At Microsoft, we recognize that AI is reshaping the global economy and society at an extraordinary speed. And no single company, sector, institution, or individual can fully understand all of its implications alone or understand what it takes to be able to scale this in a way that leads to a supportive and inclusive world that we want. So this includes not just the opportunities that AI creates, but also the risks, uncertainties, and environmental footprint associated with it. This is why Microsoft is actively engaging with scholars and experts globally to help inform and shape this new era of AI to be secure, equitable, and sustainable. And it's also why Microsoft recently launched the AI Economy Institute, which explores these very issues, works and supports and invests in independent research to be able to inform this new AI economy. And this report that we co-produced with the Veolia Institute, that were the foundation of the conversation we have today, was produced in collaboration with the AI Institute and also produced to inform the Institute's work with industries like the environmental services industries, but also the Institute's work more broadly and the industry's work more broadly on sustainability. So now let me turn to a few themes that stood out for me as I worked with the collaborators who contributed to this report and also in producing the report itself. The first is trade-offs and uncertainties. AI can dramatically accelerate sustainability solutions, but net positive outcomes don't happen automatically. They require deliberate choices, continuous evaluations as the technology and solutions evolve. The second theme that stood out is governance and guardrails. Strong policy frameworks, shared priorities, and cross-sector collaborations are essential to ensure that AI supports sustainability goals, and especially in the context of energy, water, and waste systems. The third is equity and inclusion. AI must be developed and deployed in ways that reflect local context and expand access rather than reinforcing existing divides. And finally, trust and readiness. Transparency, high-quality data, infrastructure, and workforce capacity are foundational to turning technical capability into long-lasting, sustainable impact. So this report is really part of our shared learning journey, of our shared with Veolia Institute, with all of the contributors to this report, all of our partners, they were going along this journey with us. And our hope is that it will help other practitioners, policymakers, and researchers navigate the complexity ahead and accelerate the responsible use of AI to strengthen the systems that we all depend on. So thank you for letting me be part of this conversation. I am sorry I can't be there in person, but I look forward to listening to the recording.
Bonjour à tous, je suis...
Hello, everyone. I am David Menachet, the director of Archipel & Co., and it will be an honor to be moderating our panel in just a minute. But before this, we have the great pleasure and the honor to have the keynote by Philippe Aguillot, who needs no introduction, but he did receive the Nobel Prize in Economics last year. Thank you very much for being here, Philippe, and to get us started thinking about the potential and the risk of AI for the environment. Once again, thank you very much for being here, and you have the floor, Philippe. Well, thank you very much for having asked me to provide the keynote speech for this conference. It's been very enriching to join the Scientific Council of the Veolia Institute with Dina, who plays a very important role. It's fundamental. And it quickly stimulated my research. So I've talked a little bit about what I've done. I have Mathias Sivilantola, Benjamin Anjou, who are here. There's also a co-author who's in Zurich, Eline Barrage. Together, we attempted to carry out research that we never would have been able to carry out without your support of the Institute. It has been absolutely crucial. So let me say a few words about the environment. This is something that we all know. This is the change in world GDP since 2,000 years, the past 1,000. And this is the Madison curve. He was an economist called Madison. He worked a lot at the OECD, and he tried to reconstitute the evolution of world GDP, or perhaps per capita, with urbanization and a variety of other factors, because we did not have INSEE, the National Statistics Institute, at the time. And what he was able to show is that growth is actually quite a recent phenomenon. It started about 200 years ago. Okay, why don't I take a microphone here?
Mobile, là c'est bien, oui.
Like way I can move around. So growth is actually a recent phenomenon. It's only 200 years old, so that, and even though I'm old, it's over 3 times my age. And before, there was pretty much no growth. There were episodes such as Venice, but those were very short episodes. And so growth started with the first Industrial Revolution and the steam engine, and that's where growth took off, and especially in 1820. If you look at changes in world temperatures, you can see that it also takes off at exactly the same time. as the industry takes off. So I'm amongst those who believe that global warming has a lot to do with growth. That is something that I share with economists who work on degrowth, but that's only one idea I share with them. But human activity is responsible for global warming, and it has to do with growth, or else the coincidence between the two curves is very striking. And given that, and even more recently, we can see China and India, their CO2 emissions start rising when their growth also starts rising in these countries. Once again, there seems to be a link between CO2 emissions and growth in human activities. So you can have two different attitudes. You can say, okay, since growth leads to global warming, let's stop growth. Let's go back to the way things were. We have known this, and this was during COVID, actually, and lockdown 6 years ago. So between March, May, and June 2020, GDP in France dropped by 25%, and CO2 emissions dropped by 8%. So we know that degrowth is possible, but it comes at a huge cost. Even for us, we sacrificed younger generations. We had to at the time. We didn't have vaccines. And then in developing countries, this translated by famine and mortality, which spiked. And not only because of COVID, but just because growth had slowed down. So degrowth is won't really work. That's for the bourgeois. I'm a bourgeois myself, but we're the only ones who can afford this idea of degrowth. It's not something that's going to please somebody in a developing country. So green innovation is another way. Saying, okay, so let's innovate and not innovate in polluting technologies, but rather green innovations. Okay, green innovation covers a lot. Innovations in our own behaviors. We can share ideas with people who are in favor of doing away with growth, saying, okay, let me not turn all the lights on at the same time, not take an airplane every day, be a little bit respectful of the environment. That is very important, but there are also technological innovations that can help. This is mitigation. This is innovation which aim to slow down global warming. If you have cleaner energy sources, nuclear energy, for example, is a way of reducing global warming. Renewable energy as well. And in this case, this is mitigation. If you can produce with using less energy, this also mitigates these effects. Then you have what we call, we'll have adaptation before improvements, but so adaptation and innovation. This is things like digs or boulders or air conditioning. In a place where the temperatures go above 50 degrees Celsius, you need air conditioning or else you can't do anything. So you need air conditioning, and you have to make it as cheap as possible that consumes as little energy as possible. So there's a whole series of innovations. And then with sea levels rising, then you have to build dams. And so we need to innovate in the technology we use to build dams. And then there's improvement. These are people who work on technologies to cool air. For example, in Harvard, the physics department, they work on geoengineering. You know that when there are volcanic eruptions, there is sulfur in the air, and that puts a screen between us and the sun, and this cools air down. So what they're trying to do is to master that technology so that they can produce the same effect and use it by minimizing secondary impacts. And this is a technique that's been developed. Other people think, okay, well, how can I maybe put huge screens in space between us and the sun? So when I talk about this, a lot of people snicker. But if we're not able to fight climate change, entire countries are going to have to devote themselves to geoengineering because otherwise life will be unlivable. So green innovation. The trouble is that there is the path dependency. Countries which have innovated in polluting technologies in the past tend to continue to innovate with polluting technologies. I worked on a study on automobile industry, and I've showed that automobile producers who innovated a lot in combustion engines continue to innovate in that area. They stick to what they've done. And so it's up to the states themselves to push companies into green innovations through things like carbon taxes, but also an industrial policy which favors the environment. This has happened in Europe, in the United States, in China, but in France we preferred a carbon tax, but then that led to the yellow vests. So only taxing carbon isn't enough. You need a stick and a carrot. So now let's talk a little bit about AI. I had the great good fortune to co-chair an AI committee with Nguvo 2 years ago, and we provided a report to the President of the Republic, and it served as a basis for France's position during the AI summit that took place a year ago in Paris. This year it will be taking place in India. And this is a report which was very useful for the French government. There are a number of recommendations. And one of the things we say is that AI has huge potential for growth because AI can make it possible to automate tasks in producing goods and services and to automate tasks in services to do with ideas. It's much easier to have ideas thanks to AI. Very often, new ideas are just recombinations of old ideas. And it's much easier to recombine things with AI. And it's easier to select things amongst these recombined ideas that you want to experiment with. And I never thought that it would be more difficult to have ideas, contrary to some colleagues, but definitely not with AI. I think it'll be much easier to have ideas. For example, my friend Jean Tirole was saying that before to prove something it took 2 or 3 days, but today with AI it takes 15 minutes. And so it's an unbelievable research tool. And the potential for growth is huge. It can also create jobs because companies that use AI are becoming more productive, so more competitive. So worldwide demand for their products increases. That leads to more jobs. AI allows you to have more new ideas, and that leads to more jobs. Of course, AI can also destroy jobs because a job is a number of tasks, and there are a lot of tasks that AI can do. So the people who do those jobs are at risk. But there is a huge potential to create jobs if the policy makers are behind the idea. We need competition policy because otherwise just a few companies will dominate everything, and this will prevent the rise of new innovative companies. And if we don't have the right competition policy, you won't be able to really profit from the growth potential of AI. There's also a potential to create jobs. Again, you need flexi-security. I'm very Danish. I believe in flexi-security, as the Danish do. And I believe in having the right type of educational system and the right type of labor market policies so that you can easily create jobs and accompany people who will be losing their jobs. So we need to help individuals transition from their old job to new jobs. And here I believe very deeply in the Danish system if it's based on a solid education system. So we list a number of policies in our report, and we also talk about the environment. On growth, we try to assess the potential for growth. We said that AI could probably increase world growth by 0.7% every year. So it's 1.7% per year over 10 years. And this doesn't take into account the fact that it's easier to have ideas with AI. So there's true potential for growth, which we've tried to assess in the report. For jobs in French companies, a poll has shown that so far, AI has had a positive effect on jobs. For now, it could change tomorrow. On the environment, so far, people have, we mostly spoken about generalities in our report. We say that the increase in energy consumption due to the development of AI does lead to a lot of people worrying. Doesn't take rocket science to realize that we might have resource scarcity. And it's had an increase of increasing energy consumption by 15% per year, and this is set to continue up until 2030 as established by the International Energy Agency. We all know that AI uses energy. And a lot of people are now saying, okay, AI has created a problem for the environment. But on the other end, because that's the negative side of things, but on the positive side, AI can also make it possible to better use scarce resources. Thanks to efficiency gains, it makes possible. So we can strongly reduce our greenhouse gas emissions in a number of sectors: transport, energy, lodging. So in our report, we say that AI can help manage scarce resources, and AI can also help companies to move away from path dependency. As I said, companies that tended to innovate in polluting areas tend to continue innovating in those areas. But thanks to AI, I think we can reduce the cost of transitioning to more virtuous activities. It will come at a cost, but we really do believe that AI will make it easier for companies to transition towards less polluting technologies. So companies are at the heart of everything because innovation is carried out by companies. Governments can help. They can assist them in adopting new technologies and transitioning to cleaner technologies through carbon taxes or incentives for innovation. Government can do that sort of thing, but the heart of the matter is companies. Companies are the ones that innovate. So there's a question of transforming companies, which is essential here. And this brings us to Veolia. So what has happened at Veolia? They use AI in a variety of ways, but what I found interesting, when we had our very first scientific committee, somebody came and presented saying, AI can help us save energy. And this stuck in my mind, and with Mathias, Céline, Benjamin, and Lit, we started this project where we thought, okay, let's look at this more closely. Let's zoom in and focus on something very specific, which is aeration systems to purify wastewater. And let's look at what AI makes it possible to save in terms of energy to treat wastewater. AI uses energy, so we thought we'll look at, okay, exactly how much the net results are. Does AI make it possible to save more energy than it actually uses to come up with these solutions to save energy? So we look at the net result. AI makes it possible to create digital twins of the wastewater treatment systems. So you've got the actual physical system and then a digital twin, which you reproduce thanks to AI. And my co-authors, of course, can always say, wait, Philippe, that's wrong. You're completely mistaken as to what we're doing. But so with the digital twins, it makes it possible to better use the systems, and especially aeration systems, because you don't want to leave it on the whole time. And it really depends on the wastewater coming in or how polluted this wastewater is. Then you can adjust. You can adjust the aeration system, and AI can really help you do this and save energy. Otherwise, you have to leave it on all the time. And that can be a waste. And so what we did is between 2022 and 2023, we carried out a large-scale experiment which led to 200 Veolia wastewater treatment centers to use AI in a variety of ways. So the gradual deployment of AI is continuing today. And it's always useful when you deploy things gradually because then you have a treatment and then you have a control group. It's just like in medicine. You need a double-blind test. You want to test a vaccine. You say, okay, you'll get the vaccine, and the others, they will get a placebo. And then you compare the changes in both groups in terms of the impact on their health. So those who get the vaccine and those who get the placebo, who only got the placebo.
Là, on va faire pareil. Il y a des
And we're going to do the same thing. Whatchamacallit? A number of Veolia sites are using AI, while others have yet to implement AI, and we're going to compare performance between those two groups. So let's look at the impact of embracing AI. We're comparing AI-driven facilities. So the experimental, or rather the control group, at the same time are suffering a shutdown. And this means that their initial parameters are reset. So we're comparing the two groups, and one of the groups has a malfunction. What's great is that a malfunction is something exogenous. It's not something that you self-inflict. And so you compare performance between AI-driven facilities and other facilities that, for whatever reason, are experimenting a malfunction. So we're looking at the impact of AI, all else being equal. Because obviously we need to ensure comparability between the two groups. And as you can see on the graph, there's a ramp up. So what are we seeing? I won't take up too much of your time. I was assigned 20 minutes, and I have just 5 minutes and a half left. Now here's the thing. Artificial intelligence. Here we're looking at the stage where there's not yet a difference between the two groups. It's important for there to be no difference between the beginning of the test. But as soon as the treatment group is deviating away from the control group, what we're seeing is that energy consumption, CO2 emissions, and energy costs drop for the treatment group as opposed to the control group. And this is significant. So on average, AI reduces electricity consumption by 5.4%, reduces CO2 emissions by 6%, and energy costs by 8.2%. So these are AI-driven energy savings. But if we look at the energy consumption of AI, what happens? So what's wonderful is that we traveled to Rennes, 90 minutes away from Paris by train, and they spent a whole day there. How many times did you go? Once. Anyway, so to look at AI's net impact, we also examine the electricity consumption of the servers on which the AI operates. And their consumption represents less than 1% of the gains achieved. So even under the most conservative life cycle analyses, AI's net impact remains largely positive. And so the reduction in energy use has not come at the expense of effluent quality. On the contrary, instances of exceeding legal discharge limits have decreased. So the cost of activating those aeration systems is much smaller than the savings generated by AI. So a very positive net impact. Now, we need to look at the impact on weather events. If we look at rainfall, as measured in millimeter. So if we manage and look at rainfall, if rainfall exceeds 5 millimeters 10 millimeter, 15 millimeter, those are the thresholds. So what are we seeing? Obviously, the more it rains, the higher the electricity consumption. It makes sense because we need to process more rainfall, and therefore you need more electricity. But when you use AI, there's more red than blue. So in statistical regression, on the left, you look at electricity consumption. On the right-hand side, you're multiplying that by coefficients. And what we're seeing here is a negative impact. So, of course, when it rains more, we tend to use more AI and consume more energy than when it's not raining. But this means you use less energy when AI is activated. And the more it rains, the more AI makes a difference. The more, on the one hand, you need to activate the system, and therefore you need to consume more energy to activate those aeration systems, but the more AI makes a difference. So AI makes a difference on average, but that difference is even bigger the harder it rains, because like I said, this is an exogenous factor. An exogenous factor that increases the amounts and the volumes of rainwater you need to process. And so AI enables more precise management of energy consumption. It adapts to fluctuations in both the volume and quality of incoming water at treatment plants. AI can anticipate the arrival of heavy rainfall events. And also, AI makes it possible to reallocate energy consumption between peak hours and off-peak hours. So thanks to AI, we can address the challenge of electricity flexibility. Obviously, you pay a premium for electricity during peak hours. This is exactly what I'm dealing with at the moment. Pricing water consumption. So what are we seeing on this chart? Just before the exit, the peak consumption stage, energy consumption is going to rise and then suddenly drop right afterwards. Same thing here. When you leave the peak hour period, just before that threshold, thanks to AI, we're going to reduce energy consumption and increase it much more right after you exit that peak hour period. And this is how we can behave more flexibly. And this is useful for smart management of electric vehicle charging that can reduce peak hour demand by more than 40%. So we observe the same effect of consumption reallocation. Aeration can be intelligently delayed by a few hours or brought forward, which generates significant effects around peak and off-peak tariff transitions. And at scale, greater tariff flexibility would make it possible to substantially shift industrial electricity consumption. So that's very interesting. We're using AI for managing processing of wastewater. And there are similar gains when it comes to EV charging. Conclusion. Industrial data flows are becoming a strategic asset for businesses, which must improve how they measure, store, analyze, leverage, and protect them. And the question of data value enhancement in industry is becoming critical. The adoption of AI and digital twin solutions is a major lever for energy efficiency and decarbonization, and yet it remains largely underexploited. And many barriers persist today, including shortages of IT skills and organizational challenges in implementing these solutions. Now, Céline and I wrote a book together, and we agree that changing organizational methods takes a while because there's always resistance to change. And AI is an integral part of the response to the flexibility challenge facing energy systems, as well as to the expected increase in severe climate-related disruptions. However, these tools are extremely useful, and they're still insufficiently integrated into energy and industrial system planning models. Thank you. And I'm going to leave it at that.
Je reviens à mes co-auteurs. Voilà.
Un très grand merci. Merci beaucoup.
Remercier eux.
Thank you, and thank you to my co-authors. Philippe, why don't you stick around? I'd like to request that our various panel members join us on stage. Let me grab hold of my cup. I wouldn't want you to get germs from my cup.
Alors, ce que je vous propose, peut-être Corinne, mettez-vous là. Corinne, je vous en prie. Je vais me mettre ici. Albert, Fouad, Philippe, ça vous va? Hop. Eh bien, donc, rebonjour à...
Welcome back, everyone. Many thanks to the panel members for attending this roundtable discussion. We're looking at the impact of AI on environmental services. So, 3 stages in this process. We'll have enough time for Q&A, no worries. It's okay to overspill. So like I said, 3 segments in our discussion. As Philippe Aguillon discussed, there's just potential when it comes to AI and the impact of AI on environmental services. So let's be optimistic and let's look at that potential. And segment number 2, we will look at the risks, the negative impacts, and also mitigation strategies. Strategies for mitigation, improvement, or adaptation. And lastly, we will look at the conditions for success when it comes to scaling up. We'll look at the potential, we'll look at the risks, but if we take things up a notch, how do we successfully manage this twofold transition? So let's put our thinking caps on. Allow me to introduce to you our speakers. Corinne de Bilbao, thank you for being here. You're the president of Microsoft of France. Corinne has a lot of experience in energy. You spent over 20 years working with and for GE, General Electric, so you know the field of energy inside and out. Philippe Gizik, you're the chief AI officer at ADEME agency, and in a past life, you were in charge of digital transformation at the Environmental and Governmental Agency. Fouad Mac, you're a part of Veolia. You're the head of architecture, engineering, and expertise at Veolia, more specifically within the Information Systems Division. Thank you. Thank you for helping us understand a variety of user cases beyond those already referenced by the previous speakers. And Albert Mege, Associate Director, Partner and Global Director of the Blue Shift Institute. And recently you published a report on the hidden costs of AI, as well as impacts on vulnerability. So thank you to our 4 panel members. Let me start with you, Albert, regarding the potential of artificial intelligence. Philippe Aguillon talked about this at great length, but I'd like to hear your point of view. By and large, what are the main areas where environmental services can improve thanks to AI? Hello, everyone. Thank you for this kind introduction. As been said, I'm a partner in Arthur Doolittle, and I'm also in charge of our Blue Shift Institute, which is a global institute. Our task is to explore, anticipate the impact of technologies on the world of business, of course, but also the world at large. There are two reports that we published recently that are relevant to today's discussion. Report number 1, it came out last year. It's called We Are Doomed, Now What? In this report, we explore issues pertaining to adaptation in the face of climate change. As Philippe rightly said in his introduction, there are 3 main issues: attenuation or mitigation, adaptation. We decided to focus on adaptation. So what do? We based ourselves on IPCC scenarios. We looked at the most likely scenario, the +3-degree global temperature increase by 2100. We looked at the biological and geophysical impacts as modeled by IPCC, and then we translated that into potential challenges for businesses. So 3 main categories of challenges. Firstly, continuity of supply. Secondly, continuity of production. And thirdly, protection of industrial assets, particularly in regions that are subject to severe weather events as a result of climate change. So that's what we've done. And based on those challenges, we looked at the top adaptation strategies for businesses in order to address the 3 top challenges that we referenced. So looking at adaptation, we specifically looked at the different categories of technologies that can help us address those challenges. So there are 3 main categories of technologies that address all 3 challenges. And one such technology is AI. Digital and AI. Philippe talked about that in his introduction. Why AI? Because I'd like to reference a number of examples in addition to those referenced by Philippe earlier. Weather forecasting. If we look at our history, weather forecasts are based on physical models, based on fluid mechanics. We can improve both the speed of convergence of those models, but also accuracy of the models by using AI. That's what Google does with its GraphCast model. That's what NVIDIA is doing with its model called Earth-2. So AI can help improve speed and accuracy of weather forecasts. Also, AI can be helpful to analyze aerial views of the Earth. After an extreme weather event as a result of climate change, you get satellite imaging. You take images taken from planes, for example, and it's faster. And it's faster to analyze those images. That means you can send rescue efforts on the ground faster after a disaster. Also, optimization of energy production and energy distribution. Again, AI can be extremely useful and enhance performance. So those are positive examples of the impact of AI. And we'll talk about the risks and the less positive aspects later. Yeah, let's start by being optimistic, and then we will move on to the dark side of AI. So some of those examples, do they seem more promising than others? Is there a hierarchy? Like I said before, those are just examples. There's an equation we need to solve. We need to solve for X. What is X? The cost of AI as opposed to the benefits of AI. And we shouldn't do this example by example. We need a holistic approach. Because if regarding the type of models I just discussed, those are not really energy or water intensive. Generative AI, for example, What are the repercussions? There's no generative AI in the repercussions I just talked about, right? I hope I've answered your question. It's my answer anyway. Thank you. Fouad, over to you. Philippe Aguillon talked about one user case specific to Veolia, but what we're interested in is to understand how industry players such as Veolia, a champion of the environmental transition, how do you factor in AI? What's the potential for AI to improve environmental services? Well, thank you. Thank you. My name is Fouad Mak. I work for IT services within Veolia. Let me try and address your question.
Ouvert à l'innovation.
Veolia has always been open to innovation and new technologies. Over its very long history, it has always been able to leverage this innovation when useful for their employees, for their operations, for their customers. IA has been present at Veolia at a very large scale for over 20 years. For the past 10 years, we have massive AI solutions deployed at a very large scale throughout Veolia. To give you just some examples, to do with water, with the water plant's performance. So we deployed AI solutions over under 320 wastewater treatment centers to treat water consumption. Energy consumption can be reduced by 40%. And other resources, the use is decreased by 60%. So this is Veolia's daily fare. Another concrete example, waste management. We have a dynamic way of following the trucks as they collect the trash to ensure that the trucks don't go anywhere where they won't be useful. And we also use AI for recycling waste. We have AI models to ensure that the quality of the air filters that we use to depollute doesn't go beyond 5%, so we can actually recycle more material. And then optimization solutions that we offer in building management. We have a solution managed by AI deployed over 2,000 projects in 38 different countries to reduce the energy consumption of our industrial clients, sometimes up to 30% in their energy consumption. Above and beyond traditional AI, we also have generative AI, which provides new possibilities, new types of capacity, which we are exploring very carefully with Veolia. We have a program we launched last year, which is called Talk to My Plant, to try to grab the benefits of AI within Veolia in order to deploy and validate on the ground through our 9 agents deployed all over the world and which are tested by our operators. The impacts are measured, are validated by people on the ground. To give you some examples, in the experimental phases, but now we're measuring impacts for energy recovery plants when we can use the heat produced by incineration of waste. Another concrete example that we've measured during the pilot phase. This has to do with producing drinking water and in desalination plants. And thanks to AI, operators can more quickly identify any leaks. They can find the right method to solve the problem, reducing the time needed to fix the problem, which formerly would have taken several hours and now can be fixed in just a few minutes, so that the drinking water can continue to be provided to the 600,000 clients. So this makes it possible to increase environmental safety, and you're all familiar with Veolia's ambitions for the environment, to depollute, decarbonize, regenerate for our municipal and our industrial clients. Thank you very much, Fouad. So Corinne, I'm turning to you. You're at the heart of the digital transformation as a president of Microsoft France. So the same question as I posed to Fouad. Seen from Microsoft's position, what do you see the potential of AI for environmental services? Thank you very much, and thank you for inviting me here. To refer to what Jean-Paul Aguillon was saying earlier, so Philippe Aguillon, new technologies and technological breakthroughs, generative AI is a technological breakthrough. They've always been scary, but at the same time, so frightening, but at the same time with huge potential. And that's where we stand today. Earlier, we were talking about steam engine. It's kind of the same time with electricity and nuclear power. This was decarbonated electricity. It also created the nuclear bomb. The goal here is to talk about what progress and what positive aspects we can find in this new technology for the environment. There are huge possibilities. Today, the climate and studies around the climate is so complex and requires so much data that human capacity to provide this data makes it impossible to solve these equations. They're much too complicated. Generative AI enables three things. First of all, to be able to quickly collect billions of data sets, to analyze them, to carry out forecasts, and also to find highly innovative solutions. I'll give you a few examples in a minute that would have been complicated or impossible to find without generative AI. And so, as Philippe said as well, Philippe Aguillon, our processing capacity for all this data are now huge. Tools for simulations are very costly. It takes a lot of time. So we worked on 2 or 3 projects, which are interesting here. So we'll talk about the weather once again, but it is an important topic, especially with the changing climate. So we have a project that was carried out based on the billions of data sets and it's a foundational model, which is 5,000 times more powerful than traditional weather forecasting tools. It can calculate wind speeds, wind directions. In the Saran storm, which led to several fatalities, and thanks to these models, we could have foreseen the storm coming several days ahead of time, and we would have known exactly where it was going to hit. So these are examples of foundational models in weather forecasting, which are extremely important because it can have disastrous consequences on humans and also in terms of financial damage. And something else is, well, protecting the environment. We have been working on a project called Wakayama. This is a project in collaboration between Microsoft AI for Good and the university to be able to forecast deforestation, because about 20 million hectares have disappeared between 2022 and 2023, and with a lot of sensors in the Amazon forest to collect data every day through satellites. And we also have acoustic traps, sound traps, to analyze over 100,000 sounds produced by birds and animals, and this makes it possible to create models to forecast animal movements, to be able to intervene rapidly if necessary to protect the Amazon forest. That's another very interesting example, which is more around protecting the environment. And my third example, perhaps closer to industry, this is work we carried out with Pacific Northwest National Laboratory on batteries to replace lithium, which is a very rare resource. So we had 32 million possible candidates, and little by little, using AI, we reduced the number of candidates. And we also added other technologies with hypercompute to then narrow it down to 20 candidates, and we're now testing this material, which would make it possible to replace lithium up to 70%. All of this shows that things can be done, and this entire process of creating the model was done in just a few weeks, whereas formerly it would have taken years to obtain the same results. So those are some very concrete examples of overall equations, which we're all interested in, thanks to generative AI. Thank you very much, Corinne. So to add to that first round of potential and opportunities, I'm turning to you again, Philippe. At ADEME, you have a project which is called SOFIA to make environmental data more reliable using a generative AI tool. Could you perhaps say a few words about this and explain how SOFIA came into being and questions around the reliability of environmental data? Yes, I will say a few words about the SOFIA project, tell you how it came into being. I saw an experiment called Climate Q&A. You may be familiar with it. It was in 2023, so it's actually quite old in AI terms. So this was a generative AI that studied all of the IPCC reports. So I looked at the tool, so Climate Q&A, it's still available. And all you had to do was to ask a question in natural language, and it would find the right answer in the right paragraph in the right report of the IPCC report. And at ADEME, we usually have the same problems as other municipal actors in terms of expertise. I've met a lot of engineers on the ground who get questions from prefects, mayors, asking the engineers, saying, okay, what's happening on the ground? How can I implement measures to adapt to climate change or to mitigate the effects? If the engineer is competent, they will probably be able to answer, but if they're actually specialized in mobility, they won't be able to help very much with wastewater treatment. So we decided to create the first reliable AI on the ecological transition. So we very quickly decided to use generative AI, and the goal became to have an ecosystem. Because as far as AI is concerned, for a variety of reasons, which we may come back to, you have to pool your efforts to collect data, pool your efforts for the technical stacks. So very quickly, we were joined by other operators, the Ministry for the Ecological Transition, and also Cerema, who is an operational cell on the ground. So today we have a documentary corpus of about 50,000 data sets. So data, so trustworthy AI. And this is because we fully master all of the data. The data is clean when it goes in, and we have a quality assurance process to make sure that generative AI is only using quality data and trustworthy data. And so why public data? Well, because this is all public data produced by experts, and it's public because we want to ensure that the tool is used by public authorities. We mostly use outside service providers to develop tools like this, but today, within the governance, technical governance, we will call upon public coders so that they can also use this tool to increase the skill set of our public coders and developers. Because one thing we've noted is that this has made it possible to reintroduce the task of being a documentalist in companies. It's a job that had disappeared, but now corpora are becoming ever more important to train AI. So data quality has become paramount. And as things progress, we will have other actors who will join us. For example, IGN for geographic data in France. We also have geological data. And there's a huge potential in concrete cases linked to the ecological transition. And then we also have MCP protocols. This is a technology which makes it possible to plug into AI systems with structured data. And you can reconcile structured and unstructured data. So for municipalities, they can ask questions, saying, for example, what are the various mitigation measures I can implement? And the system will not only look through the documentary corpus, but also will look at structured data. And the system can formulate expert recommendations. So structured and unstructured data, so documentary corpus, these are reports, these are text, and then structured data is spreadsheets, Excel files. And with the protocol, you can dialogue with structured data. So AI can go and interpret and study these structured data to provide you with an interpretation in natural language, which is quite powerful. And today we are currently creating this structured data ecosystem of the documentary expertise, and then unstructured data as well. Thank you very much, Philippe, for presenting this project. And as I said in the introduction, we wanted to start with potential solutions. And now there's the question of risks and negative impacts. Albert, through the Blue Shift Institute, you published a report around the systemic vulnerabilities caused by the hidden costs of AI, especially the environmental costs, and then more broadly, and maybe we can get back to this, this is the transparency around data, and of course a lack of transparency. Albert, maybe I could ask you to give your perspective around the major risks and major negative impacts. The report is called AI's Hidden Dependencies. It's a report that was published 3 weeks ago, and we had our launch event in France. So it's this evening at the Palais de Tokyo, our French launch event. In this report, we look at 3 major types of vulnerabilities that companies are exposed to when they use AI and when they depend on AI. So you have a strategic dependency, economic dependency, and also environmental dependency. So we'll focus on environmental dependency. And to begin, a few elements are interesting to bear in mind. You may know that there's been an explosion in the number of users of AI. In the future, this will mainly be driven by embedded uses and agentic AI. This is when your operating system or your web browser uses AI and LLM models without you even being aware of it. And this makes the number of users skyrocket. And then secondly, there's a complexification of the tasks asked of AI and also of the energy cost of the models. Let me give you some figures. If you put in a prompt with GPT-4 in OpenAI, energy consumption is more or less equivalent to a search in Google. But if you use the latest model, GPT-5, it's almost 100 times more in terms of energy consumption. And you don't necessarily realize this as a user because it's the same prompt on both ends. You think it's the same thing, but actually not at all. So when you combine this skyrocketing in the number of users, let me give you another figure, which is interesting. To generate a 5-minute video with AI is the same thing as actually charging a Tesla. So this is far from being negligible. So when you combine the skyrocketing number of users with the consumption of energy and water, you can see that these effects can be considerable. So consumption of water, energy. For water consumption, well, a data center, middle-sized data center, is the equivalent of the water consumption of a city of 20,000 inhabitants. By 2030, the consumption by all data centers will be the equivalent of the consumption of the 10 largest European cities. And last bit of food for thought. So a lot of people have said, oh, don't worry, what's expensive is to train the models. And then once the models are trained, then using them won't come at a very high cost. This is only true if there are very few prompts. But if you have hundreds of millions of users at the same time, this is not true at all. In our study, we've assessed that it's between 90 and 99% of energy consumption is during inference. So it's when it's being used and not when it's training. And then also when you're producing the microchips. And it's about the same as water consumption. So these are figures that it's important to remember, I believe. And then in addition, concerning transparency, reporting, and the general impact on energy, water consumption, rare resources. So transparency progressed up until 2023, but then it collapsed. No more transparency.
Les utilisatrices et les utilisateurs.
Today, AI users across the world, of course, there are differences from one geography to another. So users have no idea how much energy they consume. We get information because we carry out interviews, but there are very few publications. That's the dark side. Thank you. And the consequence of that is that nobody is paying for the real economic and environmental cost of AI. Nobody's picking up the tab. Thank you. Allow me to promote the report. Section 3 of the report looks at management of negative impacts of AI. And there are several papers on data center consumption, both in terms of water and energy. So feel free to dig deeper after this conference, and I strongly recommend you read all 4 sections. Corinne, over to you. Albert discussed a number of findings that are useful to keep in mind, but as the head of Microsoft France, what about your responsibilities and your strategies for addressing the repercussions that we just discussed? Earlier, we talked about energy consumption. It is true that energy consumption comes to slightly under 1%, globally speaking, but of course it's bound to rise because AI usage is booming. So energy consumption is bound to rise, is bound to skyrocket. But of course we need to look at the overall equation, the global equation, and there are lots of statistics that look at AI's energy consumption in the future and also avoided costs thanks to increased energy efficiency and throughout the supply chain. So there are lots of potential energy savings thanks to increased energy efficiency. So let's not sweep the problem under the rug. What are we going to do? Of course, we're working on energy consumption issues, and we try to make sure that we maximize the use of renewables. We need to maximize the use of renewables, and we have set a target for ourselves, 2025. Now, we've begun 2026. We have met our target. We are fully transparent. And also, renewable energy savings. We're talking 40 gigawatts thanks to long-term contracts with energy providers, and this generates a new economy for renewable energies, and that economy is something that everybody needs. And this means we can further develop renewables. We're also working on models that are less energy intensive. You talked about large language models, but one idea is to give customers a choice, give them the resources they need to choice. Okay, here I don't need to use a GPT-5. I'll use a smaller model. And so we need to empower users to make smarter choices so as to reduce energy consumption and use the most efficient AI models. Water, obviously, is a topic for discussion. And we have a closed loop data center in Zaragoza, in Spain. So you use water during the construction process, but then we use water for cooling the computers, and the water circulates, but we don't reuse it. It is important to rehydrate the water systems, and we're working on water replenishment systems. We want to replenish water supply to water scarce areas, and we're working on a number of such projects to provide drinking water to 5 million users, because older technologies don't make it possible. We're working on legacy technologies so as to retrofit them. And one last thing that we haven't talked about, but it's important, waste. We have a negative carbon footprint commitment by 2030. We have zero waste commitments. And recycling servers is also important. We have a huge recycling center in Amsterdam. Our recycling ratio is 90%. We need to bear in mind the short lifespan of those servers. Same thing for packaging. Lastly, construction. Construction of data centers requires cement and therefore causes CO2 emissions. So we're working at our research center to try to come up with new materials. That way we can reduce CO2 emissions from the construction process, maximize the use of recyclates. The recycling ratio comes to 65–70%. So obviously we haven't resolved every issue, but we're trying to be fully transparent in our reports. We have many projects, and we measure how far we've come in terms of energy, water, waste. Those are aspects that are being addressed at the highest level of leadership, and very hands-on initiatives are being taken. Could you give us examples? You also think there's room for transparency? There's room for improvement in terms of transparency? Now we publish a transparency report on where we stand. We're halfway there. And I'm not talking about the next report, but the latest. We managed to reduce our Scope 1 and Scope 2, as well as our Scope 3 emissions. Well, actually, Scope 1 and Scope 2 emissions. Unfortunately, Scope 3 emissions have increased. And one thing we never talk about is Scope 4 emissions. And we decided to look at that. We are fully transparent. When it comes to users, we've worked with a number of startup companies, a number of businesses, so as to develop tools that users can use to measure the carbon footprint. So there are different tools based on servers that are all located in Europe. Things are more complicated when it comes to the individual level. So we need to provide those measuring tools to businesses and individuals as well. So there's room for improvement. And there's a lot of demand. Over to you. Same question as for Corinne. How do you address negative repercussions, and what are your mitigation and adaptation strategies? Well, Veolia is the champion of the environmental transition. We are aware of our responsibility. The onus is on us to bring under control the ways in which we use those technologies and scale them up. Sometimes we need to make trade-offs. We need to choose between making solutions ourselves and buying them. So we rely on a platform developed internally called Value Secure GPT. And this agentic platform was built in a way that would reduce the use of LLMs. This sounds counterproductive, but let me tell you what about our approach. Systematically, we try to use small language models as opposed to LLMs as much as we can. So when you switch from an LLM to an SLM, the impact is reduced by a factor of 10. Another way in which you can further reduce your footprint is to use agentic AI as opposed to traditional AI. Agentic AI only uses an LLM if it's necessary, absolutely necessary. So sometimes the SQL request is sent to a search engine as opposed to an LLM when the LLM is not absolutely necessary. Because if you use an LLM, the cost of that request increases by a factor of 50 or 100. So in order to reduce your footprint of each request, you need to find the right documents, the right segments of the document in question, as opposed to uploading it entirely. You're not going to miss any of the information. So this requires additional effort during the design phase, so you can reduce significantly the actual use of the models. One last example, automated compaction. Say you're talking to a chatbot regarding a particular problem, you're starting to dig deeper, you're looking for potential solutions. For every iteration, instead of sending to the model the entire discussion, there's an automated compaction system and filtering system. So this reduces your footprint. This reduces by 50% the quantity of information provided to the chatbot, and therefore the quantity of information addressed by or processed by the LLM. So this much reduces your impact. But we decided to control this platform, develop it in-house, so as to combine all the technologies that we need. Another important leverage to better use these technologies, set up a strong governance system. We have a strategic program that is group-wide and that supports the most interesting projects, supports them through the pilot phase, and after the pilot phase, make sure that the environmental footprint is a positive one. And I don't just mean the economic footprint, so as to issue the go, no-go decision before scaling up. So we optimize the process using agentic AI. That way we use fewer LLMs, fewer SLMs, and instead focus on traditional algorithms. For example, if you need to make forecasts regarding energy consumption or optimizing energy instructions in a facility, we will use a traditional AI model, which is much less energy intensive, as opposed to an LLM that will gather the results of that AI model and provide it in natural language to the operator. So through all of these technical initiatives and also Veolia governance, we're able to optimize the use of AI depending on the project, and we're able to reduce the use of Gen AI thanks to the use of agentic AI. Thank you for clarifying. Philippe, I know that as part of the SOF AI project, you're also trying to minimize impacts. So this is one specific project. How did you go about it? It's true that regarding SOF AI, we tend to generate usage of AI. But I like to say that AI is a pharmacon, is both the remedy and the poison it's trying to fix. So you need to know exactly how you position yourself. Regarding Sophia, we do generate usage and queries and inference. Now, regarding data transparency. At EDEM, we have a project for life cycle analysis using Mistral because we need a repository. Very often we talk about big tech and how big they are when it comes to energy consumption and the carbon footprint of the data and the training models. Now, we're working with Mistral on the impact of models. What we're doing is a life cycle analysis. Getting back to Sophia, we had to put our thoughts together and put together a virtuous system that would limit the impact while at the same time making available expertise as broadly as possible. In a couple of months, not right away, and I'll explain to you why, here's the idea. For example, we can impose an ETS system, a carbon credit trading system, and we set up an overall carbon quota, and on the basis of membership, we could say that this overall carbon impact can be allocated equally between the different members. That would be step one, and depending on the rate of inference for each member, we could have a system where those quotas could be bought back. And why not have a virtual currency? This mechanism could work. And regarding the downstream segment, regarding actual users, the idea would not be to charge the municipalities, because if we did do that, in terms of that would not be consistent with our goal to share expertise as broadly as possible, and also there would be admin costs. So the idea would be to monitor the carbon impact generated by the municipalities and offset that at the local or regional level. And those initiatives could help offset the carbon impact of the municipality, and we would promote those virtuous initiatives. So that's what we're looking at. So the system can be as virtuous as possible. Thank you. You've been very patient. You've been very patient, thank you. So instead of looking at segment 3 right away, let's open up to questions from the audience. And I know Philippe has to leave soon. So, segment 3, prerequisites for success when it comes to scaling up. Let's now turn to the audience. Wait for Rome microphone. Introduce yourself briefly and address your question to one of the panel members. And I'd like to take this opportunity to thank the members of our panel. Now, questions. Anyone? Hello. My name is Thierry. I work for Veolia. I don't know who to direct this question to. We heard Philippe's introduction. We heard about the carrot and the stick, the positive and the negative aspects. Now, in this discussion, in the answers provided, there's something I'm not hearing. What about impetus provided by government? Do you have any expectations whether to accelerate or limit this trend? Because, as you said, any ship can turn into a shipwreck unless you do something, unless you provide a framework. Corinne, Albert, Fouad, Philippe? Who wants to take this question? I agree, we need regulation. Otherwise, short-term economic and financial priorities will dictate how we behave. As Thierry was saying regarding the AI summit, any recommendations when it comes to regulation? President Macron is in Bombay today, I think. Remember the 2023 summit in London? It mostly looked at security. And of course, security of those various mechanisms remains a key aspect, and so we need standards. ANSI is a government agency that provides excellent papers on the topic, and the latest report looks at open source and gives us ideas regarding manufacturing of generative AI. So 2023, security 2025, AI as a driver for productivity gains and economic transformation as part of a whole liberalization era. Now, since Trump, we have promoted the precautionary principle. And if we look at what Biden has been doing regarding AI security, well, from the point of view of operators or governments, we are keeping our ear to the ground, and we need a specific governance framework to steer projects forward. Now, there are pockets of opportunities and productivity, and we need a complete governance system and also pool stacks. That way, correct me if I'm wrong, but make sure that technological stacks aren't invented by different people at the same time. Why reinvent the wheel? We need to pool those stacks. In 2023, the priority was security. 2025, the idea of economic transformation. And I believe that regarding the current AI summit in India, unless I'm mistaken, the topic is sovereignty.
Qu'on doit aller sur des
And I also think we need to give much better advice on what we mean by sovereignty. It's not necessarily national sovereignty. It can also be shared at world level, but with specific behavior around competencies about source codes, etc. If I could add something, it is a wonderful opportunity for competition, and there's also need for oversight, for ethical AI, safe AI. The biggest risk today is cybersecurity attacks. And we also need to open up these ecosystems because there's no legitimacy if there are no shared values. In an acceptable manner for jobs, for the environment, for society. Where we have to be very careful is to make sure that regulation doesn't kill innovation. That's always the fear we have in Europe. Will be to not be able to move quickly with new technologies, to be competitive, because we tend to regulate before everything else. We do need regulation, we need a framework, but we also need a system which makes it possible to open the ecosystem up. You talked about Mistral earlier. That's great. These are the large language models. So we have to be careful, but we can't overregulate because everybody else will be moving on. Fouad, you wanted to come back to this as well? Yes. There are a number of frameworks depending on the geography. Currently, Veolia is trying to be a front runner. In February 2025, we signed the Responsible AI Charter, which we are committed to applying in all Veolia's companies with its best practices and its rules. We apply directly within our governance at all levels. At the same time, we need to regulate in the United States, in Europe, elsewhere in the world. Currently, there's a lack of a global framework, planet-wide framework, which would apply the same rules to everyone in a virtuous